Hi, we're here at PCI SIG DevCon 2019, and I want to share with you a full end-to-end system demo at PCIe 5.0 with Synopsys IP for PHY and controller. So let me walk you through the demo here. Starting here, we have a HAPS-80 prototyping system, FPGA, that contains the Synopsys PCIe 5.0 root complex controller IP inside there. And connected to it here, you can see a daughter card. On that daughter card, you can't really see it, but there's a PCIe 5.0 32 gigatransfers per second PHY and a PCS layer implementing the pipe interface. That comes out and connects to this interposer card here from Teledyne LaCroix, where we're intercepting the transfer and looking at the packets. Then we come over here to another PHY daughter card, another 16 gigatransfers per second PHY here. In this case, you can see it here. And then we have the PCS layer here. And then we come over through these HAPS-track ribbon cables into another HAPS-80 where we've implemented the Synopsys PCIe 5.0 endpoint controller IP. So it's a complete end-to-end system. We can move traffic in either direction. And looking at the demo, what we're doing right now is we're just showing traffic transferring at 32 gigatransfers per second, as you can see here. So one lane wide, 32 gigatransfers per second. We're at L0. And then down here, if you look at the speed, performance, you see we're at 3,480 gigabytes per second. If you do the math from a 32 gigatransfers per second data rate, you account for 128, 130 encoding, decoding, header overhead, credits, and other things that reduce the throughput. This is actually a pretty good throughput, close to the theoretical maximum. Now, let me show you just a couple other things here. If we look at the LTSSM trace view, we captured this right before the link up to show you what this looks like. So you start out at detect quiet. This is kind of the beginning of the link process. The link comes up at 2.5 gig, which is Gen 1. If I scroll down here, you can see we then start negotiating 8 gigatransfers per second. And over here, you'll see the precursor, cursor, post-cursors being negotiated. So we're trying different presets and trying to get a good link at Gen 3. Once we complete that, kind of the same process goes on at Gen 4. We try different presets to get the best link at Gen 4. All looks good. So we move on to the final goal, which is Gen 5 link up. And so we come up here and do the presets and the link up here. You can see all these changing again, sharing coefficients. And then finally, the end goal, we end up at 32 gigatransfers per second at L0. And again, that's where we are here in the performance view, 32 gigatransfers per second. Over here, this is the output of the Teledyne LaCroix protocol analyzer where we're intercepting the data. And this is just kind of a static shot showing you an example. Here, we're looking at some TLPs that have been sent. Then we get an acknowledgement of those TLPs, and then we can get update flow control, credits, etc. So this trace goes on and on. There's a lot of data that can be shown in here. And it's a great way to see that it's really PCIe Gen 5 data. It's a great way to debug the system if you wanted to do that, or your software as well. So that's the complete end-to-end system demo, and thanks for watching.